Good afternoon, sorry.
Good afternoon, Mr. Okay, the next presentation.
I'll start sharing my screen. Is that visible?
Yes. It's already, we can see.
Excellent, okay. Good afternoon, everybody. Assalamu alaikum. My name is Dr. Campbell Waddell. Thank you, Dewey, for giving me the opportunity to speak to you all today and introducing the project that we've kindly been invited to work on for the Mandalika circuit. So I'm going to go through briefly racetrack asphalt pavement. How does a racetrack pavement differ from a road or a runway? So just a little bit of background. I work for a company called R3 Limited, and we are part of the Mark 1 consulting group for this project. So in our team, helping MGPA, ITDC and PP, we're there to offer specialist advice in terms of tracks operations, which is where Mark 1 consulting come in. That's their specialty. Driven, who are the circuit designers, they are providing MGPA with all the detailed designs and all the detailed design drawings and homologation with the FIM to make sure that the racetrack conforms to current safety standards and for the design process. And we at R3 are the asphalt technical consultants. So R3's background, just a little bit, we work in partnership with Ulster University. Daru, who did the previous presentation, I believe knows my colleague and business partner, Dr. David Woodward, very well, so he's working on this project as well. And the purpose of our company is really to take our research-based approach from Ulster University and bring it to a commercial world. We currently work with FIA and F1 to improve racetracks' asphalt surfaces, and we're deep into developing innovative solutions to help understand surface characteristics in general. We've been working on racetracks in terms of providing consulting services and testing for the last 10-12 years, and my PhD was actually in the grip of motorsport surfaces. So yeah, Mandalika Grand Prix circuit. It's an exciting opportunity and a fantastic opportunity for Indonesia to showcase its engineering talents to the world. Our job is really to help advise on the difficulties and intrinsic differences between racetracks and roads, basically, for the construction process for MGPA, ITDC and PP, the principal contractor. So all the work will be done by the highly talented engineers such as Dewey and his team, and we're just there to help with the specification and making sure that the fine details that are required for FIM and to hold a world-class motorsport event are adhered to, and that they're built to that standard. So firstly, very quickly and obviously, a racetrack is not the same as a road or runway. Many people around the world think that asphalt is asphalt and you can just stick down whatever you use on your local roads and it'll be fine, but it really isn't the case. A racetrack surface, although the material looks the same, feels the same, it has to have certain characteristics and it has to be homogenized in a certain way. So really, it has to be constructed to the highest standards that are available in terms of civil engineering. The asphalt itself has to withstand really extreme forces from the tyre surface interaction. Race vehicles and the speeds that they use, the forces that are going through the tyres onto the surface in terms of lateral loads are immense, and the racetrack surface has to be able to cope with that. Also, a racetrack will develop and evolve in a different way to a road or a runway, in that all the vehicles are taking the fastest route around the track, so they're all going over the same area, and as such, the surface itself, the surface course, must be designed to be high grip or appropriate levels of grip, but designed to take this wear and be able to last over the length of the circuit design life. And because of the high speeds that the vehicles are travelling, particularly on motorbikes, you're talking speeds of 320 kilometres and above, the pilots will notice even minor bumps, small bumps, little undulations or deformities. Racing drivers and riders, pilots have very sensitive bottoms, and they will feel absolutely everything and they will complain about it. So as such, modern racetracks are expected to be very smooth and have a homogenized surface, so a very consistent surface texture, surface characteristics across the whole width and length of the racetrack. Most importantly, as such, the racetrack has to be designed for safe motorsport, and that's what FIA look for when they are when they're doing their track assessments. So the techniques that we use to build local roads, doesn't matter where you are in the world, are generally not good enough to create a world-class racing surface for a modern motorsport environment. The racetrack surface has to be constructed to the absolute highest standards from anywhere in the world. And that's to ensure the safety of the vehicles, the drivers and the spectators. But the last thing anybody wants is for part of the surface to break up or aggregate to come out and be thrown into the crowd and injure a spectator, let alone a driver or a participant or a steward. And the racetrack has to have the desired surface characteristics in regards to tyre surface interaction throughout its life. It's not something that, from a road and runway perspective, that we certainly in Europe think of particularly. How a tyre interacts with the surface isn't really considered as part of the design process for roads in the UK anyway, and it probably should be. Tyre industry and vehicle industry is moving forward so quickly, and generally speaking, for construction of roads, we do the same thing and have done for a number of years. And maybe it's time to start thinking about it another way and start learning from what motorsport can bring to the roads industry. So in regards to designing the racetrack, we think in terms of how the tyre will interact with the surface. So each layer of the asphalt as part of the pavement construction must be very, very smooth. Has to be constructed to the highest quality, using the highest quality material, from the aggregate to the bitumen to the filler to the fines. It all has to be specifically designed with the thought of motorsport and how we're going to create the desired surface characteristics that we're looking for. Because the asphalt pavement itself in a racetrack is the main asset for a racetrack. And this is particularly important for a street track, because if you're going to have standard road vehicles onto the street track, it's going to evolve slightly differently, and it's going to change and wear differently to a purpose-built racetrack that's only used for a racetrack. And as such, particularly for a project like Mandalika, which essentially is the first street circuit that MotoGP will run on, that's very, very important. So again, the racetrack must be extremely smooth, even surface with strong shear strength, and the surface texture is consistent over the entire surface and very important. So to give you an idea of the surface regularities that we're working to ensure a smooth racetrack, and this has to come from the subgrade up. So the design level tolerances are very tight and have to be monitored using a 4 meter straight edge. Nothing fancy here. We're just using a standard straight edge, but that has to be, the 4 meter straight edge has to be, and the regularity has to be the same in every direction. So not just in the direction of traffic, but across the width and laterally across the surface material. And so we're looking to create a very, very smooth surface, and that comes from the bottom up. Also, one of the requirements that we have for racetracks is macro texture. And the micro texture obviously will come from the aggregate particles themselves, but the macro texture has to be to a desired level to ensure that the tyre surface interaction is correct, and that particularly this is a major component in grip, and particularly in the lateral forces or the bulk hysteresis loss of the tyre as it slides across a racetrack surface. So we're looking for micro texture in the region of 0.9 millimeters, around about 1 millimeter, straight after construction, and this is specified throughout the design life of the asphalt material. In order to measure the macro texture, we will use a couple of different solutions. So One is the sand patch technique, which is a simple, old, classic way of measuring macro texture, but also use close-range photogrammetry and 3D modelling, as well as the International Roughness Index, which was talked about before, so I won't mention again. Also, we have to monitor the racetrack surface throughout its design, throughout its life, and that is not just after construction. The asphalt surface course has to be maintained and monitored, tested and looked after throughout its life, so before races, after races. And as part of this, it's very important that the asset is monitored and maintained, and a baseline of data is built up, and any changes in the material, in the surface characteristics, can be spotted and rectified if need be. So for this, we use simple techniques that are maybe commonly used in some parts of the world, but not in other parts. So obviously, the simple one is a visual pavement in survey. And so experts walking the track, knowing what they're looking for, and looking for deformities or changes. We at R3, we have a system called GripMap, where we use a continuous friction measuring device to measure the friction characteristics of the entire track surface. This allows us to look for any changes in undulation or any bumps, but also ensure that the friction characteristics are as you would expect and to an appropriate level for the type of motorsport that is going to be happening on the surface. Sand patch test, it's still the standard. It's not the greatest test in the world, but as I say, it's still the standard around the world, so it will give us an idea of mean texture depth. And then we use the process close-range photogrammetry, or UU-TEX 3D, as we call it, to measure the surface characteristics and area parameters using 3D modelling. We also look at compacted profile smoothness using the 4-metre straight edge, LiDAR surveys. So the LiDAR surveys give us a base layer and will show us smoothness compliance using static LiDAR devices, which was what we were intending to use for Mandalika. Or sometimes we use mobile mapping if it's available in the local area. And that's basically a 3D scan of the entire track. And we can layer the data using a planner to see how any changes down to millimetre level, sub-millimetre level, any changes over the entire track. Profilometer as well, we will use profilometer for longitudinal surface profile, roughness and macro texture measurement. So that will give us our IRI, International Roughness Index, and ensure that the surface is as we would expect it to be and suitable for racing. So this will be done after the construction of the surface course, and then it should be done before every race, 12 weeks before, to give time to do any remedial work that's required, and again throughout a race event to see how the surface is changing. So some details on the asphalt material that we're proposing to use for the surface course. Where the aggregate that we'll be using is going to be a PSV of 55 or above. Some racetracks around the world, for example Silverstone, we use a higher PSV aggregate because it's locally available. We're trying to use our aggregate that is available in Indonesia. We don't want to ship in aggregate from England or Europe or even America with very high PSV. There's not very high PSV aggregate available in America, but we don't want to ship that in from somewhere else. We want to try and use local Indonesian materials, partly for the environment, partly for environmental reasons, and also because if there's a suitable aggregate available, which there is, then we should use that. There's no point in just trying to conform to test for one individual part of the material, when we can use a suitable aggregate that's available locally and have the performance of the overall output of the asphalt itself. As Dewey said earlier, we'll be using a polymer modified bitumen with a high softening point, and we're looking at using a 10mm SMA, which will give us appropriate levels of grip, so 65 plus pendulum values, and smoothness in terms of IRI of less than 1 metre over 1 kilometre. And this is very difficult to achieve. So how are we going to achieve it? How do we create a world-class racetrack asphalt pavement? Well, the main thing to consider is quality control. Quality control will be critical at every single stage. We need high levels of quality control and quality assurance And as the previous presenter, Daru, pointed out, some of the techniques that have been used elsewhere in the world and that are being adopted by companies such as AECOM and Highways England. These can be adapted and used for racetracks as well. So every piece of material, equipment, process must be tested, and tested again. There will be, as part of the testing process, we'll be doing a trial site on the service roads, as Dewey said, and that's where everything will be tested over and over again. This will be done using everything, including the people and staff that will be laying the actual track surface itself. And it will take quite a wee while to get that right, but once it's right, we'll make sure that when we lay the surface course, it'll be as good as possible. And every member of the team, from the engineers to the construction workers, from the bottom up, are really important to success. It'll be very important to get everybody to buy in, because all it will take is for one of the pavers to be bumped by a truck loading it and reversing into it, for there to be a ripple or bump in the track, and that's not what we want. So everybody needs to buy in and work together. And so team training, practice is going to be key to success, to make sure that every asphalt layer is constructed to precision. In terms of the materials that we're looking at using, it's the best quality materials that we have available. So the aggregate will have a good high PSV, not very, very high, but suitable. But more importantly, the shape, the mineralogy and rock type have to be correct. In terms of bitumen, polymer modified, high quality fibres and a high softening point. And the equipment, as Dewey pointed out, we'll be using new modern pavers and rollers, GPS levelling systems, and high output asphalt mixing plant. But people are key to success, so it's going to be about getting everybody to work together, buy in, and make sure that we're all working to the same quality plan and working together. So in order to do this, we can't have any longitudinal joints in the surface, so the paving must be done in continuous echelon, so 3 pavers operating together. We're using 3 pavers for the job, 3 identical pavers, to ensure that we get the appropriate quality of asphalt material and ensure it's homogenised across the width of the track for the entire circuit. The reason we use 3 pavers in echelon and not just 1 or 2, which are wider, is because of the tight bends and the radiuses that we have to use as part of the track, and the 3 pavers make it easier to get round and keep a consistent material and producing that consistent surface course. So any lateral joints as well, they have to be planned. The plan is to do it 1 continuous rip of the surface course, so starting and then not stopping the pavers until we finish. And the asphalt has to be rolled to perfection. The roller drivers are very important here, because this all has to be planned to the finest detail. If we overroll the mix, we might crush the aggregate and therefore not meet the specifications that are required in terms of micro texture. As I mentioned earlier, feeding the pavers without the trucks touching the pavers is going to be paramount to success. You use power feeders if they're available. This isn't always the case. So it's going to be about ensuring that the truck drivers know what they're doing. They have appropriate banksmen to make sure the pavers come back properly, and it's all controlled. We'll have GPS levelling systems on the pavers using the TopCon system, which will help ensure the conformity of the smoothness of the track, and controlled rolling patterns. So this is a little video that's from Tarmac, from when they resurfaced Silverstone. I'm just going to play it just now and let you see, and it gives you an idea of the construction process and the techniques that are required throughout to produce a world-class racing facility.
Silverstone, it really is important. So for us, it's really important.
This is the 3rd Formula 1 track we've done, so we've obviously got a reputation for it.
We produce the best scheme possible with the best results using the best resources.
When the construction crews and the material business come together, then it is an awesome operation to behold.
Silverstone needed a bespoke, very high-performance surface to deal with the stresses given by Formula One cars. Everything needed to be integrated into one team. We analysed where our weaknesses were, and where our challenges were, and we planned around them.
The aggregate from Basin has been specially chosen for its unique and specific quality. By us washing the dust, it allows the mix designers to get the correct consistencies in Silverstone racetrack, to make sure that we've got the right material in the right place and the right time.
So the key consideration is the very high shear forces exerted on the asphalt by Formula One cars, particularly under braking. They can exert enough force to create ripples in the asphalt.
Indirect tensile strength, stiffness and binder adhesion allowed us to determine the durability of the mix design. Surface friction testing is carried out in situ to ensure that the resulting material met the friction requirements of the specification.
A lot of this project has been about ensuring consistency of the surface finish and using new technology to deliver really excellent results.
Loop air bays were erected, cleaned, to make sure there's no cross-contamination. Backup procedures are in place, electricians are ready to be called out, fitters are on hand. Once the asphalt has left the mixer box, the technical department and then inspect it, temperature check, make sure it's all inspected.
Reprofile the whole circuit from taking nothing off to 140 million places. So we set up a bespoke traffic management system to minimise the amount of time that any truck spent getting through to the paving machine and reversing. Critical pressure points, other than the material specification and the parameters for the laying of that material, were for us not stopping. Once we'd started, we had to keep paving, and that's where we utilised BPO.
Being able to plan the logistics gave us a better control of getting the right rolling temperature and programming the lorries into the paving train from mix to lay.
So using BPO, we were able to look at the installation from both sides. So if we were able to produce faster, then we could lay quicker. Equally, if we weren't able to produce as fast, then we needed to lay slower. And to get that balance right can be quite hard, but using the software system, it was quick and simple.
That gave us then the ability to utilise the technology on the paving machines to get the smoothest ride possible.
We had to get a tolerance of less than 2 mil on a 4 metre beam, which is more onerous than an airfield. The consistency of the material was impeccable.
Every single truck was laid, there was no wastage.
We've done a lot of preparation, it's a prestige job.
Now we've experienced the technology that we've used on here, it'd be nice to push that forward into the future. I'm really keen that we use some of the knowledge that we've gained here and take that forward into our day-to-day business.
Because the grip levels there, we've got increased speeds, lap records have already been broken on the circuit, and it actually makes it a lot safer as well. For me, it's that British excellence, start to finish, being proud to be British and to be able to do it and stand it. So we're moving Britain forward with our technology.
So that gives you an idea of what needs to be done to create a world-class motorsport circuit, and this is all about making, showcasing Indonesian talents and engineering excellence. So once the circuit's completed and the asphalt surface course is down, it's important to remember that the racetrack has to be prepared before racing. So one of the issues that we will have will be excess bitumen, blinding the texture and the micro texture of the aggregate. So before any major event, after a new surface goes down, really important that the track is ran. So whether that's using amateur racing, just getting people on to in bikes and cars to actually race on the track surface, and makes a huge difference. You need to establish what's called the racing line, which is the fastest way around the track. In fact, if anybody is F1 fans and is watching the Turkish Grand Prix this weekend, you'll see that they are having this exact problem, which is early life skid resistance issues. They resurfaced the racetrack 2 weeks ago, and it's bitumen rich, and as such there is very low levels of grip, and the F1 cars are sliding all about the place. And the same thing will happen potentially here. So it's all about preparing the track for the race itself. As part of that, you can use potentially high pressure water retexturing, or just getting the track used. So getting people to run it with bikes, with cars, and having amateur races and preparation races before the actual event itself. So what can we learn from constructing a racetrack? Well, new civil engineering techniques, new methods of quality control, quality assurance, to build better roads and runways. This can all be taken back. And the learnings from this, the processes, the equipment, the technologies can be taken back to roads and racetracks to improve roads and racetracks, roads and runways, and make roads better quality, safer, and last longer. Performance in situ testing techniques as well, like we're using on Mandalika, and the techniques could be used to as part of asset management to improve safety of roads, and more efficient construction techniques. So not only improves safety, but also improves the whole life cost savings for the country as a whole. So in conclusion, a racetrack surface, asphalt pavement is not the same as a road or a runway. Construction of a racetrack, asphalt pavement requires the highest quality standards, materials, equipment, process and staff. And the racetrack has to be smooth, high grip and homogenised all the way across. That's really important. It's all about consistency of the surface characteristics, consistency of the material. And the tolerances that are required by Formula 1, MotoGP, FIM, FIA are far higher than you would ever have on a road or a runway. That's because of the high forces that the tyre surface interaction and the vehicles place on the surface, from the braking, cornering and accelerating. And this really is a chance to showcase Mandalika to the world. MotoGP is one of the biggest sports in the world, and everybody will be watching. So all I can say is you're lucky to have a very, very good team. Dewey and his team at MGPA are fantastic and are doing a really, really great job in getting this circuit ready and built, and the principal contractor are keen and out there pushing on, and I'm very, very sure it's going to be a great success. Thank you very much.
Okay, thank you. Thank you very much, Mr. Campbell. Thank you for the explanation is